So we need to apply here the quotient rule. And for the stationary point, what we need to do? We need to do first differentiate of the expression, then we would consider that one equals to 0 for to get the value of x of the stationary point. So we needed to apply here the quotient rule, because d by dx of ub, let you write the quotient rule first. If you don't know the detail of the quotient rule, you are welcome to click on the top right I button to see my quotient rule, few more working about the quotient rule. So the formula is v du by dx minus u dv by dx divided by v square. So that is our quotient rule formula. So if you don't know, click here, there is a I button, see in this button, just click, then we will get the detail of the quotient rule. Okay, we are going to apply here that in this expression it is written here dy, let me write dy by dx. So our u is x square we would consider as a u, and v we need to consider as a 3x minus 1. So let me put here directly, you can put there 3x minus 1, 3x minus 1, then d by dx of x square minus x square into d by dx of 3x minus 1 divided by 3x minus 1 whole square. That is our total expression. Now let us simplify the expression, which gives us 3x minus 1 into 2x, because if we differentiate x square we got 2x from there, then x square into 3x minus 1, if we differentiate we got from there 3, and the denominator it is 3x minus 1 whole square. So according to the rule dy by dx we have to consider 0, then let you consider that expression equals to 0. Then only the numerator part would remain here, because denominator goes to the right side and that whole denominator becomes 0. So only the numerator part from there is 3 to 6x square, it gives us 6x square, then minus 2x, then minus 3x square equals to 0. So it is 3x square minus 2x equals to 0. So we can take x common from there, then the remaining part is 3x minus 2 equals to 0. So we got two values of x, which is stands for the stationary point. One is 0 and another one is 2 by 3 from the expression. Now our target is to find out the y value. For getting the y value, we need to put this main x value in our main equation. Y equals to, our expression is 0 square 3 into 0 minus 1. So as a numerator 0, the whole expression becomes 0 definitely. So one stationary point which is 0 comma 0, this is our one answer from this question. And another one, when x equals to, we got 2 by 3, then we are going to find out the y as well. Y equals to 2 by 3 whole square. Let me write the value, 3 into 2 by 3 minus 1. Oh, from denominator we can write 2 minus 1, which is 1, we know, and the top one is 4 by 9. So actually it becomes 4 by 9, because denominator is gives us 1. So our another coordinate is 2 by 3 comma 4 by 9. This is our another stationary point coordinate. Another question for you, which is find the coordinates of the stationary points. That is the expression, and the expressions written as a product rule. We need to apply here the product rule. Like before, we have to apply dy by dx equals to 0. If it is written there stationary points, coordinates of the stationary points, coordinates of the turning point, coordinates of the maximum point, minimum point, everywhere we need to apply dy by dx equals to 0. So let you write first the formula for the product rule, d by dx of uv, if it is written there, then we need to apply u dv by dx plus v du by dx. So if you don't know the detail of the product rule, please see the I button from here. There is I button. So you will get a few more examples about the product rule. So let me apply here the product rule. If I write that dy by dx, then it is x d by dx of 4 minus x to the power 3 plus 4 minus x to the power 3 d by dx of x. So x into 3 4 minus x to the power square into minus 1 as well. Here we needed to apply here the chain rule. If you don't know the detail of the chain rule, please see this I button, another video for detail. So the next part is 4 minus x whole cube into 1. That is the expression. Now we are going to simplify the full expression, which is minus 3x. We can write it 4 minus x square, then plus 4 minus x to the power 3. That is our expression. We now needed to consider dy by dx equals to 0. So therefore we can write the expression, therefore minus 3x whole expression we need to consider as a 0 to get the value of x of the stationary point. Let you take 4 minus x square common. We can write the remaining part, which is minus 3x plus 4 minus x inside the second bracket, the remaining parts we wrote here. Then we got the final expression, which is 4 minus x whole square. Then another factor is 4 minus 4x equals to 0. Now we can write here 4 minus x whole square equals to 0, or another expression 4 minus 4x equals to 0. So from here you can write 4 minus x equals to 0, and the value of x we got from there, x equals to 4. So this is our x coordinate of the stationary point or turning point. Another value from here we can write it, say 4x equals to 4, then the x value is 1 from there. This is another coordinate, another x coordinate of the stationary point. Now our target is to find out the y coordinate, because coordinate means we needed to find out the x and y value both. We got the x value only. When x equals to, let me find out the y value, x equals to 4, then y equals to, we need to apply the main equation. This is our main equation to get our y value, which is, we can write it 4, then 4 minus 4 whole cube. So actually inside it is 0, so 0 into 4 it becomes 0. So one coordinate of the stationary point, which is 4 comma 0, this is our full coordinate of this question. Another one, when x equals to 1, then y equals to, we can apply this one in the main equation again, 1 into 4 minus 1 to the power 3, which gives us 3 to the power cube, which is 27. So our another coordinate of the stationary point, which is 1 and 27. So this two is our answer. This is the first answer. Another one, that is the another answer. Hope you enjoyed these videos for the stationary points, how to get out the stationary points. Thanks for your patience to seeing my video. You're welcome to see my next video as well.